What if launching a satellite into space currently costs $20,000 per kilogram, but a space elevator could reduce that to just $10? That's not science fiction. That's the revolutionary promise of space elevator technology that could fundamentally transform humanity's relationship with space. Right now, we're trapped by rockets. Every time we want to send anything beyond Earth's atmosphere, we're essentially strapping it to a controlled explosion. This isn't just expensive. It's limiting our entire species. Space elevators could change everything within the next 30 years. They represent the difference between being earthbound and becoming a truly spacefaring civilization. Picture this. A cable stretches from Earth's equator straight up into space, extending 60,000 miles beyond our atmosphere. This isn't just any cable. It's made from carbon nanotubes, material stronger than diamond yet lighter than aluminum. The cable connects to a massive counterweight stationed far beyond geostationary orbit, where centrifugal force keeps the entire structure taut like a cosmic fishing line. The physics are surprisingly elegant. Imagine spinning a ball on a string above your head. The faster you spin, the more the ball pulls outward. Earth's rotation creates this same effect on a space elevator. The counterweight wants to fly away into space, but the cable holds it back. This tension keeps the entire elevator rigid and stable. At the base, think of a gleaming platform rising from the ocean. Massive anchor points, engineered to withstand hurricane-force winds and seismic activity, secure the cable to Earth. Picture climbers, sleek vehicles the size of shipping containers, ascending this cable at hundreds of miles per hour. These aren't rockets burning fuel. They're electric vehicles drawing power from the cable itself, like trains on a vertical track to space. The journey takes days, not minutes. Passengers experience a gradual transition from Earth's gravity to weightlessness. At 22,000 miles up, they reach geostationary orbit, where satellites maintain perfect synchronization with Earth's rotation. Continue climbing, and gravity weakens further until passengers feel the strange sensation of centrifugal force pulling them away from Earth. But here's where it gets fascinating. The cable doesn't just carry people and cargo up. It generates energy coming down. Heavy materials mined from asteroids or the moon could descend the elevator, their gravitational potential energy converted into electricity. The space elevator becomes both a transport system and a power plant. The engineering challenges seem impossible until you examine them closely. Carbon nanotubes can theoretically handle the stress, but we need to manufacture them at unprecedented scales. Weather poses constant threats. Lightning strikes, high winds, and atmospheric turbulence could damage or destroy sections of the cable. Space debris traveling at 17,000 miles per hour could slice through the structure like bullets through silk. Then there's the terrorist problem nobody talks about. A space elevator represents the ultimate strategic target. Severing the cable anywhere above geostationary orbit would send thousands of miles of carbon nanotube whipping around Earth's equator at supersonic speeds. The destruction would be catastrophic. Entire cities could be leveled. This makes space elevators both humanity's greatest transportation achievement and potentially its most dangerous vulnerability. Who controls access to space when a single structure can transport unlimited cargo for nearly zero marginal cost? Currently, only wealthy nations and corporations can afford space missions. Space elevators could democratize space access, but they could also concentrate unprecedented power in whoever operates them. Imagine if a single company controlled all access to space. They would effectively hold Earth hostage. There's also the geopolitical nightmare. Space elevators must be built on the equator for physics reasons. This limits locations to a handful of countries, many politically unstable. Would Ecuador or Kenya become the most strategically important real estate on Earth? Would superpowers go to war over equatorial territory? The environmental impact cuts both ways. Space elevators could eliminate rocket pollution, but constructing them requires massive industrial operations. Mining materials for carbon nanotubes could devastate ecosystems. The counterweight alone would require resources equivalent to building thousands of skyscrapers. But if we solve these challenges, space elevators reshape human civilization completely. Manufacturing moves to space, where zero gravity enables perfect spheres and impossible crystalline structures. Abundant solar energy becomes available 24 hours a day, unfiltered by atmosphere or weather. Asteroid mining brings precious metals back to Earth in quantities that crash commodity markets. Population pressure disappears when space habitats become affordable. Climate change becomes manageable when we can launch massive solar shields or atmospheric processors. The Moon transforms from a distant destination into a suburban commute. Mars colonies become economically viable when transport costs drop by 99%. Space elevators create the ultimate economic disruption. Entire industries become obsolete overnight. Rocket manufacturers disappear. Satellite companies collapse as space-based solar power makes terrestrial energy generation irrelevant. But new industries emerge. Space hotels, asteroid mining corporations, and orbital manufacturing facilities become trillion-dollar sectors. The timeline matters crucially. Japan and several private companies are targeting the 2050s for operational space elevators. China has announced even more aggressive timelines. The first nation to complete a space elevator gains insurmountable advantages in space access, resource acquisition, and technological development. This isn't just about transportation. Space elevators represent the moment humans stop being a single-planet species. They're the bridge between being earthbound and becoming citizens of the solar system. Every major civilization advance required new transportation methods. Roads enabled the Roman Empire. Ships created global trade. Railroads built modern nations. Space elevators could build our cosmic future. The question isn't whether space elevators are possible. The question is whether we're brave enough to build them despite the risks. And whether we're smart enough to manage the consequences when we do. Subscribe to VoidViz to decode tomorrow's tech.